Hello viewers, in this video we are going to have an introduction to integration. Let us just know what integration is all about. Okay, now integration is just the reverse of differentiation, the converse. If you try to redo what we did in the process of differentiating a function, we get what we call the integration of the function. So integration is the reverse, the converse of differentiation. Remember that when we discussed differentiation, I told you that differentiation is just the rate of change of one quantity with respect to another quantity. Take for example now, when you have that y is equal to 5x squared plus 3, for instance, if I want to differentiate this function now, I'll have dy over dx, okay, which will give me 5 is here, the power will come to the back, I'll have 2x, 2 minus 1. From what I told you in my videos on differentiation, whenever you differentiate any constant, it will give you 0. So here, my dy over dx will give me 10x, because 2 minus 1 is nothing. Again, if I have that y is equal to 3x power of 4, for instance, and I still want to differentiate this particular function, I will have that my dy over dx is the something as 3 is here already, 4 will come to the back, x 4 minus 1. So dy dx will just give me 12x. 4 minus 1 is just 3. So we are getting 12x power of 3. Now, what if we want to reverse this to get the original function? That is where integral takes place. And integration is just the reverse of differentiation. Okay? And the symbol for integration is just this elongated s. Looks like an elongated s. So now, if I want to get back this particular function with respect to x, so I have to integrate with respect to x both sides, integrate with respect to x. So that the x will cancel the x, I'll have just integral dy equals integral of 12x power of 3 dx. Now, the formula for differentiation will tell you that if you have something like 12x power of 3 here, the formula will tell you add 1 to the power. If I want to integrate it, add 1 to the power, because in differentiation we subtracted 1. Okay? So the reverse means adding 1 to the power all over whatever you are having here, bring it down also. So 3 plus 1, I'll bring down my 3 plus 1. Okay? And this is something as 12x power of 4, because 3 plus 1 is 4, all over 4. When I divide 12 by 4, it will give me 3x to the power of 4. You can see we've got this back. But this integral dy is something as 1 dy. Okay, because 1 times dy is still the same thing as dy. Okay, and 1 is the same thing as y power of 0, because y power of 0 will give me 1 here. Okay, so this is something as saying integral of y power of 0 dy equals, when we integrated this here, we got 3x power of 4. So this is just 3x to the power of 4. Now, trying to integrate this, I have y power of 0 plus 1 over 0 plus 1 equals 3x to the power of 4. You will now see that y plus 0 plus 1 will still give us y. So this is just y. Y over 1 is still y, equals 3x to the power of 4. You can see that the original function has been got back again. So this process of reversing a differentiated function to get the original function is what we call integration. And that is why I am telling you that integration is just the reverse of differentiation. And whenever you integrate a function, we normally say plus the constant of integration, plus c, constant of integration. You understand why we normally add this constant c in this particular example here. So let me wipe off here so that we come to this particular example, and that will tell you why we normally add the letter c, which is the constant of integration, after every integral. Now see, when I differentiated this function, I got 10x. Now, if I want to get this back, the idea is to integrate, okay? So I'll integrate both sides now to see if I'm going to get this back. If I integrate this, I would have just the original function y equals, remember the formula, this x is just like 1. Without the power is 1. Then from the formula of integration, add 1 again over 1 plus 1. Whatever you're having here, bring it down. We always add 1 to the power because in differentiation, we are subtracting 1. So y will give me 10x squared all over 2 because 1 plus 1 will give us 2. And when I divide 10 by 2, I'll have that my y equals 5x squared. 10 over 2 will give us 5. You can see here that I was able to get 5x squared, but I couldn't get the constant c. So sometimes the constants are lost while differentiating a function. And in the process of integrating it back to get the original function, we cannot recover that constant again most times. That is why after every integral, we normally say plus the constant of integration. That constant that you must have lost while differentiating a function. You can only get by the constant when some information are revealed. Okay, that is the definite integral. When it is definite, you can still get back the value of c when you are given certain information. Aside that information, this c will be lost. And that is why you must add plus c after every integral you've made. Remember, I told you that integration is just the reverse, the converse, the opposite of differentiation. You are building back what differentiation has already destroyed. So let me give you the formula for integration again, and we take just one problem in this video, and you have to expect subsequent videos of mine under integration where we shall take integration bit by bit for proper understanding. Okay, now supposing you have a function, let's say y equals x power of n, for instance. Okay, or maybe you have a function x power of n, you want to integrate this function. The rule will tell you that the integral of this function with respect to x is the same thing as x, that n, which is the power, add 1 to it. Bring whatever you are having there to the numerator plus 1, then you add the constant of integration. That is how you integrate a function. Whatever you're having as the power, add 1 to it. Bring it down, finish. Then you add the constant of integration. So supposing you are asked to integrate, let's say 6x power of 2 with respect to x. This the x means we are integrating with respect to x. This is just 6 is here, x. The power is 2. Add 1 to the power from the formula over whatever you're having here, bring it down, 2 plus 1. Then you say plus c, the constant of integration. So we shall have now 6x power of 3 all over 3 plus c. Okay, now 6 divided by 3 will give us 2. So this is just 2x to the power of 3 plus the constant of integration. So this is just the integral of this particular function. So you've now seen how to integrate a function, and when I differentiate this again, I will still get this thing back again. So you can see that integration and differentiation are just cat and dog. Whatever integration destroys, whatever differentiation destroys, integration builds it back again. And that is why I told you that integration is a converse of differentiation. Expect next episode on integration where I shall deal with it bit by bit. If you've enjoyed what you've watched, kindly subscribe to my channel to be updated whenever I upload a new video. Thank you.